Hello, learners. Welcome to our virtual room, and let's begin our discussion by answering this question. What makes planet Earth unique? Now, there can be a lot of answers, but one of those is that planet Earth is special because it is an ocean planet, meaning it has a presence of liquid water, which covers 70% of Earth's surface. Also, planet Earth is habitable with a distance of almost 150 billion meters from the Sun, which considered as the right distance that shelters from the worst of the Sun's rays. Another explanation would be the presence of greenhouse effect. Now, when we say greenhouse effect, it is the process by which radiation from a planet's atmosphere warms the planet's surface to a temperature above. Furthermore, planet Earth is unique and special because it is the only planet which has favorable conditions that support life. It is neither too hot nor too cold. Greenhouse effect contains carbon dioxide, methane, and nitrous oxide. Okay, now since I've mentioned already the unique characteristic of the Earth, now let's talk about now the Earth systems. Now question, how do Earth subsystems affect one another? Now before we answer that question, let us define first what is a system. Okay? A system is defined as a collection of interrelated parts forming a synergistic whole that jointly perform functions that each part by itself cannot perform. In other words, a group of parts that function together. Now we have two types of a system. We have open and closed system. An open system interacts with its environment while closed system does not. Again, systems that have relatively limited interaction with its environment are therefore considered as closed systems, while those with substantial interaction are considered as open systems. However, all systems require energy source to drive them or to perform them. Now the question, how can the two types of a system, which is open and closed systems, are connected with each other? Okay, so the answer would be the closed system is comprised of four open systems. We have the atmosphere, biosphere, hydrosphere, and lithosphere. Now the arrows indicate flows between the system. For instance, the atmosphere and biosphere continually exchange energy such as heat and mass such as water vapor, carbon dioxide, and oxygen across their system boundaries. This also happens with the other open systems. Now, to answer this question, how do Earth subsystems affect one another? For example, the Jace the Earth system, I should say, has four subsystems called the lithosphere, hydrosphere, biosphere, and atmosphere. Now, because these subsystems interact with each other and the biosphere, they work together to influence the climate and trigger geological processes, and it affects life all over the Earth. Now, to better understand the topic for today, let me first discuss the four open systems. First, we have the atmosphere. The atmosphere contains all the air in Earth's system, and it extends from less than 1 meter below the planet's surface to more than 10,000 kilometers above the planet's surface. Now, the upper portion of the atmosphere protects the organisms of the biosphere from the sun's ultraviolet radiation. Also, it absorbs and emits heat. We also have layers of the atmosphere. From the bottom to top, we have troposphere, which contains convection currents created by the sun's heat, which cause most of our weather. Hence, most of the weather occur in this region. Next, we have stratosphere, which contains the ozone layer, which prevents some ultraviolet radiation or UV light from reaching Earth's surface. Also, this is where airplanes fly. Next, we have mesosphere. Meteors burn up when they hit this layer. Next, we have the thermosphere, where satellites and radio waves travel in this layer, and this is considered as the hottest layer. We have the thermosphere. The next open system, we have the hydrosphere, and it has something to do with hydrologic cycle, and this is the continuous movement of water from oceans and freshwater sources to the air, land, and back to the bodies of water, which results in fresh water continuously being renewed. So this is the picture of the water cycle. Now the hydrosphere has an abundant substance which covers 70% of the Earth's surface, with a breakdown of 97% of water that can be found in oceans, and 3% is fresh water. Now, in the context of Mindanao, we have Mindanao River Basin. We have 5 provinces that includes Bukidnon, Maguindanao, North Cotabato, South Cotabato, and Sultan Kudarat, and 3 regions that includes Region 10, 12, and ARMM, and we have 2 cities, Cotabato City and Coronadal City. For a total land area of 21,503 kilometer per square meters, and this is the second largest river basin in the Philippines. Okay, the next open system, we have the biosphere, and within the biosphere, living things form ecological communities based on the physical surroundings of an area. Now, these communities are referred to as biomes. And under this open system, we also have the hierarchy of life from the atom, molecule, macromolecule, organelle, cell, tissue, organ systems, the organisms, population, community, up until biosphere. In other words, Earth's organisms live in the biosphere. Now, the biosphere consists of the parts of the planet in which all life exists. Lastly, we have the lithosphere, which contains all of the cold, hard, solid land of the planet's crust or the planet's surface. And again, all of these open systems are connected with each other. Now, let's proceed to the layers of the Earth. Now, so that we can fully understand the concepts of earthquake generation, we need to discuss the dynamics of the layers of the Earth. The interior of the Earth is divided into layers based on chemical and physical properties. So we have here crust, mantle, outer core, and lastly, we have the inner core. Okay, let me discuss first the inner core. When we say inner core, this is primarily solid sphere about 2,440 kilometer in thickness, situated at Earth's center. The inner core is believed to be composed primarily of a nickel-iron alloy with small amounts of some unknown elements. The temperature is estimated at 5,000 to 6,000 degrees Celsius, and the pressure to be about 330 to 360 gigapascal. The next layer, we have the outer core. The liquid outer core is 2,300 kilometer thick and, like the inner core, composed of a nickel-iron alloy, but this time with less iron than the solid inner core. Now, seismic and other geophysical evidence indicates that the outer core is so hot that the metals are in a liquid state. And next, we have mantle. The mantle is approximately 2,900 kilometers thick and comprises 70% of the Earth's volume. Now, it is composed of magnesium and iron, and consider this as the thickest layer. And lastly, we have the outermost layer, which is the crust. Now, this is the most familiar to us because this is where we live. Okay? Now, the crust is like the skin of an apple. It is very thin in comparison to the other three layers. Now, the crust is only about 8 kilometers thick under the oceans or the oceanic crust, and about 32 kilometers thick under the continents or the continental crust. In continuation, we have tectonic plates. When we say tectonic plates, the crust of the earth is broken into many pieces called tectonic plates. The plates float on the soft, semi-rigid asthenosphere. What is asthenosphere? This is located in the middle mantle, and the movement of the asthenosphere is the reason that the crustal plates of the earth move. Now, to further explain regarding tectonic plates, it is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movement and different phenomena, including mountain building events, volcanoes, and earthquakes.